In the beginning, there is silence, an endless canvas of blackness stretching beyond imagination. Then, faintly, threads of light emerge, weaving across the abyss. These are not mere streaks of brilliance, but colossal structures, strands of galaxies stretching millions of light-years, vast and delicate at the same time. It is as though the universe itself has been spun by an invisible hand, pulling together filaments that trace the hidden skeleton of reality. To look upon them is to feel both awe and terror, for they reveal how small we truly are in a universe of unimaginable scale. But what are these threads? They are not random. They form a pattern, a lattice that binds the cosmos together. Galaxies cluster along these filaments like luminous beads strung along the fibers of an unseen web. The voids in between are emptier than deserts, swallowing light and sound in their stillness. These structures, stitched across billions of light-years, are the highways of matter and energy. They are the architecture of existence. Yet for all their immensity, their shape whispers of something eerily familiar, something that does not belong to the heavens at all, but to us. Deep inside the human skull lies another universe. It is far smaller, bound within the fragile walls of bone and flesh, yet it hums with a complexity that rivals the stars. There, billions of neurons stretch out tendrils, branching into tangled webs of connections. They fire with pulses of electricity, sparking thought, memory, and emotion. To peer at them through a microscope is to see a ghostly resemblance to the cosmic web. Delicate strands stretch across space, clusters forming nodes, pathways echoing infinity. One is written in galaxies, the other in cells, but both seem to speak the same visual language. How could such a likeness exist across scales so staggeringly different? This is where mystery takes hold. We are taught to see the brain and the cosmos as separate realms. One is inner, intimate, fragile. The other is outer, eternal, vast. Yet when the images are placed side by side, the cosmic web of galaxies and the neural network of the human brain, the resemblance is undeniable. Are we looking at coincidence, a trick of the mind that finds patterns where none exist? Or are we glimpsing a universal principle, a design that threads its way through every level of reality? Imagine a single spark of thought leaping across a synapse, igniting a memory or idea. Now imagine an entire galaxy glowing in a filament, a beacon of light surrounded by emptiness. Both are nodes in a greater system, connected, dependent on their neighbors, unable to exist in isolation. The brain is the seat of consciousness, the place where awareness flickers into being. The universe is the stage upon which existence unfolds, an endless expanse where matter gathers and disperses. And between them lies the haunting possibility that the two are reflections of one another, mirrors held across the vast divide of scale. For centuries, humans have gazed upward, searching the night sky for meaning. We mapped constellations, traced gods and myths among the stars, and wondered whether the heavens themselves were alive. Now, with the precision of modern science, we uncover structures that echo our own biology. The question returns, sharpened. Is the universe a mind, and are we its fleeting thoughts? Or are we simply projecting our own reflection upon the cosmos, as we have always done? The opening thread of this story is not an answer, but a challenge. The filaments of galaxies stretch across the abyss, whispering of order hidden in chaos. The neurons of the brain fire endlessly, weaving consciousness out of electric sparks. Two realms, one incomprehensibly vast, the other profoundly intimate, appear to follow the same script. To step into this mystery is to confront a truth both exhilarating and unsettling. The universe and the mind may not be strangers after all. They may be chapters of the same story, written in different languages, waiting for us to learn how to read them. A vast expanse unfolds before the mind's eye, not as empty space, but as a tapestry woven in threads of invisible matter. Astronomers call it the cosmic web, the hidden scaffolding of the universe. Stretching across billions of light years, these filaments form the largest structures known to science. Galaxies are not scattered randomly. Instead, they gather along these cosmic strands, luminous islands strung like pearls on vast threads. Between them yawns the great void, immense regions almost devoid of galaxies, dark hollows where silence reigns. The contrast is breathtaking: emptiness and fullness, order and chaos, void and filament. It is in this delicate balance that the architecture of the cosmos reveals itself. To truly grasp its scale, imagine a map spanning the observable universe. Each dot is not a star, but an entire galaxy, each containing billions of stars of its own. When plotted together, they form intricate bridges of matter flowing into each other like rivers of light across a dark plain. These filaments can stretch hundreds of millions of light-years long, yet they are surprisingly thin compared to their length, like strands of silk stretched taut across the night. At their intersections lie dense clusters of galaxies, the crowded cities of the cosmic web, while between them stretch the silent deserts of intergalactic voids. This is not chaos. Beneath the apparent randomness lies an elegant order, born in the first moments after the Big Bang. Tiny fluctuations in the newborn universe, slight ripples in the distribution of matter, expanded under gravity's pull, growing into rivers and strands. Over billions of years, these filaments became the highways of cosmic evolution. Gas and dust flowed along them, feeding galaxies, igniting stars, and giving rise to planets. The very atoms in our bodies, forged in stellar furnaces, once traveled these filaments like passengers carried by unseen currents. To look upon the cosmic web is to glimpse our ancestry written across space itself. The web is not just vast, it is dynamic. Gravity pulls matter inward, while dark energy pushes space apart. These opposing forces sculpt the filaments, stretching them, shaping them, sometimes tearing them apart. Astronomers simulate this dance with supercomputers, generating images that look less like physics and more like art, networks of glowing veins against a backdrop of emptiness. Strikingly, these simulations resemble the tangled wiring of biological tissue, as though the universe itself were a living organism, pulsing with hidden energy. Is this resemblance a coincidence of form, or a clue that the laws governing life and cosmos are intertwined? The more we study the filaments, the more they reveal their dual nature, fragile yet enduring, delicate yet vast. A single filament can span distances greater than the human mind can truly comprehend, yet it may be only a fraction of the width of the entire cosmic stage. They are highways of creation, and without them galaxies would scatter adrift, isolated, unable to grow. If the universe is a grand design, these filaments are its threads, binding matter into a coherent whole. And yet, here lies the mystery. When images of the cosmic web are placed beside those of the brain's neural network, the resemblance is unsettling. Both are built of filaments, both dotted with glowing nodes, both stretched across a void. One connects neurons with electrical signals, the other binds galaxies with gravity and dark matter. One gives rise to thoughts, memories, and awareness. The other gives rise to galaxies, stars, and worlds. The question stirs: do they mirror one another by chance, or do they spring from the same universal principle? The narrative of the cosmic web is not only scientific, it is deeply human. For in the end, these strands are not just maps of galaxies, but reflections of our own longing to understand. We stare into the abyss and see threads of light weaving order out of darkness. We trace those patterns and recognize something familiar, as though the universe itself were whispering back to us. You are not separate. You are woven into this fabric, a fleeting thought in a mind that spans the stars. The story of the cosmic web is the story of connection. It is the story of light carving paths through emptiness, of matter arranging itself into networks that sustain existence. It is the story of how we, born of stardust, now turn our gaze upon the threads of creation and wonder what they mean. In these filaments, we see not only the architecture of the cosmos, but perhaps the reflection of ourselves. Beneath the vault of the skull lies a universe no telescope can see. It is not made of galaxies or nebulae, but of cells so small they vanish into shadows when stripped of light. Yet, when magnified, they reveal a wilderness more intricate than any constellation. The human brain contains roughly 86 billion neurons, each branching like a tree, each reaching out to connect with thousands of neighbors. Their connections form synapses, tiny bridges where pulses of electricity leap across the gaps like lightning striking from cloud to cloud. The result is a web, dense and tangled, but alive with motion, a forest where sparks race and vanish in a rhythm older than memory. If the cosmic web is the architecture of galaxies, then the neural network is the architecture of thought. In the span of a heartbeat, millions of electrical signals travel across its highways, carrying the weight of sensation, memory, and decision. Neurons do not shine with stars, yet when visualized with modern imaging, they glow eerily in branching clusters, their signals pulsing like flickering constellations. It is here, in this labyrinth of cells, that every dream, every fear, every moment of awareness has ever lived. And though it spans only the width of two hands cupped together, the brain contains more complexity than the entire universe we can see. At first glance, the brain and the cosmos appear to belong to opposite domains. One is small enough to cradle in the hands, the other extends beyond billions of light years. One is fragile, dissolving with age and decay. The other is bound by forces that will last until time itself runs out. Yet, when their structures are mapped side by side, the tangled filaments of neurons and the sprawling threads of galaxies, the likeness is haunting. Both form networks of nodes connected by strands. Both show clusters dense with activity, surrounded by wide spaces of silence. Both suggest that nature, when left to its own devices, tends to weave existence into webs. Inside the cavern of the mind, a neuron fires. An electrical impulse leaps across a synapse, triggering another, then another, until waves of activity ripple outward. In this, there is rhythm, a pulse that becomes thought, memory, or imagination. Across the abyss of space, gravity pulls galaxies together, funneling gas and matter along cosmic filaments, feeding clusters where stars ignite and die. Here, too, there is rhythm, galaxies forming, colliding, merging, fading. One unfolds in milliseconds, the other in billions of years, yet both are governed by connections, by the flow of energy through filaments. And here lies the question that gnaws at the edges of understanding. Why? Why should two realms, separated by scale beyond comprehension, mirror each other in form? Is it coincidence, a trick of human perception eager to find patterns? Or is it a hint that the same fundamental laws guide both the firing of a neuron and the clustering of galaxies? To step into this thought is to walk a tightrope between science and philosophy, between the measurable and the mysterious. The intimacy of the brain makes the resemblance even more uncanny. Unlike the cosmic web, which exists far beyond human touch, the neural network is not just visible, it is us. Every spark across a neuron is part of the story of being alive. Every pattern is part of what makes us remember a face, feel sorrow, or imagine infinity. To realize that the cosmos might share this architecture is to wonder whether consciousness itself is written into the universe's design. Yet the resemblance also unsettles. If the brain is a reflection of the cosmos, then are we simply echoes of a larger system? Are our thoughts not truly our own, but sparks in a mind beyond our comprehension? Or does the likeness reveal the opposite? That the universe is not alive at all, and that the patterns of galaxies are only cold imitations of the living networks inside our skulls? The resemblance raises as much unease as wonder, for it blurs the line between the human and the cosmic, between the thinker and the stage upon which all thought occurs. Inside the cavern of the mind, neurons whisper to one another, weaving the fabric of awareness. In the vast reaches of space, galaxies cluster along filaments, weaving the fabric of existence. Between them lies a gulf that no ship or thought can cross, yet in their forms there is a bridge, an echo that demands to be understood. As we move deeper into this mystery, we must ask not only how these webs are alike, but what it means that they are. From the moment humans first looked upward at the stars, we have carried an instinct, a hunger, to find meaning in the chaos. A night sky scattered with points of light could have been nothing more than random pinpricks, yet ancient stargazers connected them into shapes, into myths, into stories of gods and heroes. In their imagination, order bloomed where disorder seemed to reign. This pattern-seeking impulse is not confined to the stars. It is embedded deep in the machinery of the human brain. We are creatures who survive by finding connections between events, between faces, between causes and effects. To see a pattern is to feel a sense of control in a world too vast and unpredictable to fully grasp. But there is danger in this gift. The same instinct that allows us to recognize a predator's shadow in the grass also leads us to see figures in clouds, omens in eclipses, and meaning in accidents of chance. Scientists call it apophenia, the tendency to perceive order where none exists. In the comparison of the cosmic web and the human brain, the question looms: are we truly glimpsing a profound truth, or are we once again tracing constellations in the dark, imposing our need for meaning upon the void? When astronomers lay out simulations of the cosmic web, the resemblance to the neural network is immediate and striking. Filaments, nodes, voids, they mirror the structures mapped in the human brain. Images of neurons firing and galaxies clustering can, at times, seem indistinguishable. Yet resemblance is not proof. The danger lies in mistaking form for function, similarity for significance. A snowflake and a fingerprint both spiral with intricate geometry, but they do not reveal the same story. And yet the pull of wonder is hard to resist. The parallels invite speculation. What if the resemblance is not superficial? What if both brain and cosmos obey the same universal mathematics, the same hidden laws that shape complexity from simplicity? Scale-free networks, fractals, self-organization, these are patterns that recur in rivers, in lightning, in the veins of leaves, in the way traffic flows, even in the architecture of the internet. Could it be that the universe has only a handful of building rules, repeated endlessly across size and form? The contrast between skepticism and belief is what makes this mystery so powerful. On one side stand the skeptics, insisting that we are fooled by our own hunger for order. The cosmos is not alive, they argue. It does not think, does not remember, does not dream. The resemblance between neurons and galaxies is as shallow as the likeness between a seashell and a spiral galaxy. an echo of geometry, nothing more. To insist otherwise is to abandon science for myth. On the other side stand the dreamers, the seekers of hidden unity. They look at the filaments of galaxies and the filaments of neurons and feel that they are staring into a mirror. They suggest that perhaps the universe is not indifferent but conscious, that perhaps our own awareness is a small reflection of its larger mind. They wonder whether thought itself is a cosmic phenomenon, not confined to our skulls, but woven into the very fabric of spacetime. Between these poles of skepticism and wonder, the story sharpens. We are trapped between the fear of self-deception and the thrill of revelation. The human brain demands meaning. The universe offers shapes that tempt us to believe. Are we discovering the truth of a hidden order, or are we merely gazing at our reflection projected onto the stars? The tension itself is what compels us forward, because the question refuses to be silenced. Patterns in chaos define our search for knowledge. Science itself is the practice of pulling order from the noise, of uncovering laws beneath the surface of phenomena. The difference between superstition and discovery is proof. But before proof comes the spark of recognition, the haunting sense that what we are seeing is not random, but part of something larger. That spark is where curiosity begins, and it is curiosity that has carried us from myth to mathematics, from starlight to simulation. In the mirrored webs of the brain and the cosmos, we stand once again at that threshold. We see the pattern, we feel the pull, and we are left with a question that will not let us go. Are we staring at coincidence or at the fingerprints of something vast, something that has been weaving the same design into every corner of existence since the beginning of time? Long before telescopes revealed the filaments of galaxies, long before microscopes uncovered the forests of neurons, human beings were already imagining the universe as something alive, something that thought and breathed as we do. In temples lit by firelight, on mountaintops where stars glittered like watchful eyes, philosophers and mystics whispered that the cosmos was a mind, a great being whose thoughts became worlds and whose dreams became destinies. These were not idle fantasies. They were attempts to understand why the sky mirrored our inner world, why the rhythm of the heavens seemed to echo the rhythm of human life. The Greeks spoke of the cosmos not simply as a physical arrangement of stars, but as a living order. Plato described a world soul, an animating principle binding the universe together, a harmony that extended from the motions of planets to the workings of the human spirit. The Stoics believed in the logos, a rational fire coursing through all things, guiding events with unseen wisdom. In ancient India, seers imagined Brahman, the infinite consciousness of the universe, of which every mind is but a fragment, a ripple on the surface of an endless ocean. Across the world, in countless traditions, the same idea returned in different names. The universe was not dead matter, but mind-like, conscious in ways beyond human measure. Such visions might seem naive from the standpoint of modern science, yet they reveal a profound intuition. Long before data and equations, humans sensed that reality might be unified, that the patterns of thought and the patterns of stars were not strangers. Myths of sky gods and cosmic minds were the first metaphors for what science now calls structure and order. When people looked up at the stars, they saw more than light. They saw themselves reflected back, and in that reflection, they found meaning. The contrast is striking when set against the language of modern physics. Where ancient philosophers spoke of spirits, today we speak of gravity, dark matter, and quantum fields. Where mystics described consciousness woven through the cosmos, scientists describe particles clustering along filaments shaped by invisible forces. And yet, despite the shift in vocabulary, the imagery remains uncannily similar. Webs, networks, invisible threads binding the many into one. Could it be that ancient imagination and modern observation are not enemies, but echoes of the same pursuit? To dismiss the ancients outright is to overlook a subtle truth. Myth was humanity's first science. It was an attempt to build a bridge between the visible and the invisible, between the known and the unknowable. And sometimes, intuition precedes explanation. The idea of a living universe, though unprovable in its mystical form, foreshadowed discoveries we now take for granted, that the cosmos is structured, that it evolves, that it holds hidden order beneath apparent chaos. But here lies the tension. Was the ancient vision of a conscious cosmos merely projection, the human mind painting its own likeness upon the stars? Or was it a glimpse, however poetic, of a truth science is only beginning to unravel, that the universe is not inert, but patterned in ways eerily akin to thought itself? The echoes of these old ideas still reverberate in modern debates, whispered beneath the language of mathematics, re-emerging when scientists describe the universe as a network, an information field, a computational system. As we stand on the threshold between myth and physics, between poetry and proof, we find ourselves haunted by the same question the ancients once asked under starlit skies. Is the universe alive with thought, or is the resemblance to a mind nothing more than a trick of perception? The answer remains hidden, suspended between awe and doubt, but the persistence of the question reveals something essential. Across time, across cultures, humans have been unable to shake the feeling that the cosmos does not merely surround us. It speaks to us in a language both ancient and new. In the realm of numbers and simulations, the mystery sharpens. When scientists step back from poetry and myth, when they reduce galaxies and neurons alike to data points and connections, a startling resemblance emerges. In one corner of a supercomputer, the universe is recreated in mathematical form. Filaments of dark matter stretch across an infinite grid, galaxies glittering at their intersections. In another lab, neurons and synapses are mapped with high-resolution scans, reduced to nodes and links in a digital brain. Place these images side by side, and the question no longer feels like metaphor, it looks like measurement. Researchers comparing the two systems speak of scale-free networks. These are webs where a few highly connected nodes anchor the structure, while countless others branch off with fewer links. The Internet is such a network. So are airline routes, power grids, and social connections. Remarkably, both the cosmic web and the human brain obey this same mathematical architecture. In the universe, galaxy clusters act as hubs, binding together filaments of galaxies. In the brain, certain neurons serve as hubs, linking circuits of thought and memory. Both are efficient, resilient, and self-organizing, properties nature seems to favor across scales. Another echo lies in fractal geometry. Zoom into a neuron, and its branching resembles the branching of dendrites, which in turn resemble trees, rivers, lightning. Zoom into a cosmic filament, and the clusters resemble smaller clusters, repeating like a pattern carved by an invisible hand. The geometry of self-similarity pervades nature, suggesting that the same simple rules may underlie structures from the microscopic to the cosmic. Could it be that the brain and the universe are not just metaphorically alike, but shaped by identical mathematical laws? The numbers deepen the intrigue. A team of researchers once compared the cosmic web's distribution of galaxies to the distribution of neural networks. They measured how information, or, in the case of galaxies, energy and matter, travels through the system. The result: both the brain and the cosmos process flows with near-identical efficiency. One transmits electrical impulses, The other channels gravitational energy and gas, but the network dynamics align in surprising ways. To those who study complexity, this is no coincidence. It is evidence that the laws of organization are universal. And yet, skeptics remind us to tread carefully. Numbers may align, but similarity is not sameness. The brain is not simply a miniature universe, nor is the universe merely a giant brain. Their resemblances are structural, not functional, or so the cautious argue. A galaxy does not think when it clusters with its neighbors. A neuron does not orbit another neuron like a star. The risk lies in confusing analogy with identity, in mistaking rhyme for reason. But even within skepticism, a spark of wonder lingers. If nature favors certain mathematical patterns, if scale-free networks, fractals, and flows emerge again and again, then perhaps it is no accident that the brain and the universe look alike. Perhaps this is not coincidence, but convergence. Just as rivers, lungs, and tree branches all follow the logic of branching efficiency, so too might neurons and galaxies follow the logic of networks. The pattern may not prove consciousness on a cosmic scale, but it does reveal unity, laws of order echoing from the smallest spark to the largest cluster. The mathematics of resemblance forces us to look beyond metaphor and into principle. Whether or not the universe thinks, it builds itself in ways that rhyme with the way thought itself is wired. The numbers suggest a deeper language, one written not in words or images, but in structure, symmetry, and scale. To listen to that language is to glimpse the possibility that the universe and the mind are chapters of the same code, repeating themselves in endless variations across the canvas of existence. Between the immeasurable vastness of the cosmos and the fragile intimacy of the human brain lies a chasm of scale so staggering it defies comprehension. And yet, within that gulf, an uncanny reflection emerges. On one side, galaxies stretch across billions of light years, flowing along filaments like rivers of stars. On the other side, neurons fire across microscopic synapses, sparking the fragile miracle of thought. Two scales that should be irreconcilable seem instead to echo one another, like mirrors facing across eternity. To contemplate this contrast is to feel both awe and unease. The universe, immense and ancient, appears eternal in comparison to the fleeting span of human life. Our brains, fragile and temporary, flicker with consciousness for mere decades before falling silent. And yet, within that brief flicker, we can map galaxies, simulate cosmic webs, and imagine infinities that will outlast us. It is as though the brain, so small it can be held within two hands, dares to hold the universe within its thoughts. Here, intimacy meets infinity. A single neuron firing may seem insignificant, but when multiplied across billions, it gives rise to awareness, the very thing allowing us to ponder the cosmos. In turn, a single galaxy drifting in space may seem lost in endless darkness, but when placed within a filament, it becomes part of a structure so grand it shapes the fate of the universe itself. Both neuron and galaxy exist in networks. Both depend on connections to give them meaning. Alone, they are fragments. Together, they are systems alive with possibility. And here, another question rises sharper than before. If the brain mirrors the cosmos in form, could it also mirror it in function? Could consciousness itself exist not only within skulls, but across scales of reality? Might the universe, vast and interconnected, hold a kind of awareness far beyond human imagination? To ask this is to walk the edge of science and philosophy, balancing between what can be measured and what can only be felt. Skeptics remind us of the limits. The brain's connections carry signals, meaning memories. The universe's filaments carry matter, light, gravity. One gives rise to thought, the other to structure. But the resemblance forces us to pause. If both rely on networks, on flows across filaments, then perhaps the difference is not as absolute as it seems. Perhaps consciousness is not a miracle confined to biology, but a phenomenon of connection itself, emerging whenever a system becomes complex enough to weave awareness from the flow of energy. The intimacy of human life magnifies the mystery. Every joy, every sorrow, every fleeting idea exists because neurons connect, fire, and fade. Each of us is a small, temporary node in the vast lineage of thought. Yet at the same time, those thoughts reach outward, mapping galaxies, naming stars, writing stories that will outlast their creators. The finite brain contains infinite imagination, echoing the infinite cosmos it seeks to understand. It is as though infinity and intimacy were never truly separate, but threads of the same fabric woven at different scales. To stand between these reflections is to feel the paradox of existence. We are tiny, fragile, brief, yet we carry within us the ability to imagine the eternal. We are finite beings who grasp infinite patterns. And in that paradox lies a haunting possibility. The universe and the mind may not be opposites at all, but mirrors, each gazing at the other across the gulf of scale, each giving the other meaning simply by existing. Energy is the hidden current that binds both neuron and galaxy, the unseen rhythm beating across scales. In the brain, it is the whisper of electricity, ions rushing across synapses, sparks leaping from cell to cell in cascades of thought. In the cosmos, it is the tug of gravity, the pull of dark matter, and the radiant glow of stars. Strip away the details, and both systems are not just structures of nodes and filaments, they are symphonies of energy in motion, orchestrated across time and space. Picture a single neuron firing. The charge races down its axon like a streak of lightning, triggering neurotransmitters that cross an infinitesimal gulf to awaken the next cell. This dance, repeated trillions of times each second, gives rise to everything we know: language, memory, imagination. Now picture an entire galaxy moving along a filament, its mass tugging on the space around it, gas and dust streaming inward, feeding new stars. Gravity, the slowest of conductors, writes a symphony on a canvas of billions of years. The tempos differ, yet both are songs of energy flowing across a web of connections. Scientists have begun to recognize these parallels in striking ways. Both networks rely on energy not just to exist, but to remain alive. A brain starved of energy falls into silence. A filament deprived of gas and matter withers into emptiness. Both require constant flow, constant motion, to sustain their complexity. In the brain, electrical impulses are transient, flickering in milliseconds. In the cosmos, gravitational currents unfold slowly, threading galaxies together over eons. One is intimate and immediate, the other eternal and glacial, yet both depend on the same principle. Without energy, the web collapses. What deepens the wonder is how elegantly these flows organize themselves. Neurons conserve energy by building efficient pathways, firing along the most direct routes when possible, but rerouting through complex circuits when needed. The cosmic web behaves in kind. Matter flows along filaments not randomly, but through channels carved by gravity, directing gas into galaxies where it fuels star formation. Both systems waste nothing. Both evolve toward efficiency. It is as though the universe, in every scale, has written energy into the grammar of order. But with beauty comes fragility. The brain's harmony is precarious, too much or too little energy, and thought collapses into seizure or silence. Likewise, galaxies rely on a delicate balance. Too much turbulence and they tear themselves apart, too little and they drift into stagnation. Energy is not simply a resource. It is the pulse of life and structure, the heartbeat of both neuron and cosmos. Here the question sharpens again. Are we witnessing coincidence, or are we glimpsing a deeper truth, that energy itself sculpts reality into the same forms, regardless of scale? If neurons and galaxies both weave their structures from currents of flow, then perhaps the web is not just a metaphor. Perhaps the universe and the brain are written in the same physics, their differences a matter of scale rather than kind. The emotional weight of this realization is profound. To think that the crackle of electricity in our brains echoes the gravitational pull of galaxies is to feel connected not just to life on Earth, but to the fabric of the cosmos itself. Our thoughts, fleeting and fragile, become part of a grander symphony, a small echo of the same forces that ignite suns and sculpt galaxies. And yet, within this unity lies tension. Energy in both systems is not eternal. Neurons burn out, synapses weaken, awareness flickers. Stars exhaust their fuel, galaxies collide, filaments thin as the universe expands. The symphony may be grand, but it is not endless. This duality, energy as both creator and destroyer, reminds us that the harmony of webs, whether in the mind or the cosmos, is temporary. The music is fleeting, even if the score stretches across billions of years. To listen closely to these echoes is to feel awe, but also urgency. For if energy is the common thread between neuron and galaxy, then the spark within us is not separate from the fire of the stars. It is the same flame, expressed at different scales, burning through the same universal web. Order and chaos wrestle at every level of existence. In the vastness of the universe, gravity gathers scattered particles into filaments, weaving galaxies into clusters, yet entropy pulls them apart, unraveling structure into randomness. In the intimacy of the brain, neurons fire in coordinated symphonies that create thought, yet disorder lurks at the edges, misfires, decay, the constant threat of silence. This struggle is not a metaphor, it is the essence of reality. Wherever complexity arises, chaos presses against it, testing whether structure can hold. In the cosmos, the story begins with the Big Bang, an eruption of unimaginable energy where matter was scattered like sparks from a fire. Out of that initial chaos, order slowly emerged. Tiny fluctuations grew under the weight of gravity, carving rivers of matter into filaments. Galaxies ignited like lanterns along these invisible highways. The cosmic web became a triumph of order against the tide of entropy, a fragile architecture holding back the inevitable pull of randomness. Yet even now, as stars burn out and galaxies drift apart, the shadows of disorder gather, waiting for the universe to fall silent. The brain's battle is no less dramatic, though played on a much smaller stage. At any given moment, billions of neurons exchange signals in a fragile balance of harmony and disruption. Too much noise, and thoughts fragment into confusion. Too much order, and thought collapses into rigidity, unable to adapt. The brain thrives in a narrow corridor between chaos and order, a balance that allows creativity, awareness, and life itself. Disorder in the brain can take many forms: illness, memory loss, the slow decay of aging neurons. And yet, even in decline, the network resists, struggling to preserve fragments of meaning against the pull of silence. What unites both brain and cosmos is this paradox. Chaos is not only a threat, but also a source of creation. Without fluctuations in the early universe, no galaxies would have formed. Without noise in the brain, no creativity or adaptation would be possible. Too much chaos destroys, but a spark of it sustains life and structure. The interplay is delicate, a tightrope walk across existence, where balance is survival. This tension invites a haunting question. If both the cosmos and the brain survive by balancing order and chaos, does this point to a universal law? Is the struggle not accidental but fundamental, a principle woven into the fabric of reality? Some scientists argue that complexity itself is born from this balance, that systems ranging from ecosystems to economies, from neurons to galaxies, all thrive at the edge of chaos. In this view, the universe is not simply a battlefield of order versus disorder, but a dance where both are necessary partners. Philosophers take the metaphor further. If the universe is a kind of mind, then perhaps entropy is not its enemy but its shadow, an opposing force that makes awareness possible. Just as human creativity emerges from the tension between structure and imagination, perhaps cosmic order emerges only because chaos is there to resist it. This inversion unsettles us, for it suggests that disorder is not failure, but part of the design. And yet the fear remains. Entropy is relentless, patient, unstoppable. Stars will burn out, filaments will thin, galaxies will fade into darkness. Neurons will falter, memories will dissolve, consciousness will dim. The fragile victories of order are always temporary, always borrowed against the inevitable tide. The beauty lies in the defiance that against all odds, both brain and cosmos carve out islands of meaning, however fleeting. To see this parallel is to feel both dread and wonder. On one hand, it is terrifying to know that chaos will one day undo every structure. On the other, it is awe-inspiring to realize that order arises at all, that the universe and the mind both dared to push back against the void. Between entropy and emergence lies the miracle of existence, fragile yet luminous, fleeting yet profound. Imagine zooming outward from a single neuron, its branches spreading like roots. Then imagine zooming outward again, past the network of neurons, past the tissues of the brain, until the entire organ glows like a city seen from space. Now reverse the vision, zoom out from a single galaxy, its spiraling arms casting rivers of light to the cluster it belongs to the filament connecting it with countless others, until the entire cosmic web sprawls across the universe like a living map. The two journeys, though separated by unimaginable scale, echo each other with uncanny precision. This is the mystery of self-similarity, the repeating patterns that appear across levels of existence. Mathematicians call it fractal geometry, the hidden order in which small structures resemble larger ones, where nature copies itself at different scales. We see it in the branching of rivers, in the veins of leaves, in the jagged outline of coastlines. We see it in lightning that cracks across the sky, and in the delicate branching of a lung's airways. And we see it, most astonishingly, in the mirrored webs of neurons and galaxies. The principle is simple. Complexity arises when simple rules repeat themselves again and again. A fractal curve emerges from a single equation. A branching tree grows by following a rule of splitting, repeated countless times. In the same way, neurons and galaxies may follow universal rules of connection. Their webs, though born of different forces, electricity and chemistry on one side, gravity and dark matter on the other, produce forms that rhyme across the abyss of scale. It is not that the brain is a miniature universe, or the universe a colossal brain, but that both obey the same mathematics of structure. This realization changes how we see the divide between large and small. To the human mind, scale is everything. A neuron seems infinitesimal, a galaxy incomprehensibly vast. Yet in the language of fractals, scale is irrelevant. Zoom in or zoom out, and the pattern repeats, echoing itself endlessly. In this sense, neurons and galaxies are not opposites but reflections, different verses in the same poem of geometry. The emotional effect is profound. If the same design governs both our thoughts and the stars, then perhaps the boundary between self and cosmos is thinner than we imagine. Perhaps the brain's filaments are not just coincidences of biology, but echoes of a deeper language written into the universe. When we look at the night sky, we may not just be looking outward, we may be looking at a larger version of ourselves. And yet this beauty carries unease. Fractals suggest order, but they also suggest infinity, a pattern that never ends. To follow the geometry is to fall into an endless mirror, zooming forever inward or outward without finding a bottom. What does it mean if the universe is structured this way? If there is no smallest or largest scale, only infinite repetition? Are we a thought within a greater brain, which itself is a neuron in a still greater mind, worlds nested within worlds without end? The mirror of scales challenges the very boundaries of perception. It blurs the line between microcosm and macrocosm, between the inner universe of the mind and the outer universe of galaxies. To live in such a universe is to exist inside a hall of mirrors, where every reflection leads to another, where the human brain and the cosmic web are not separate mysteries, but pieces of the same infinite design. Time is the thread that both weaves and unravels the webs of brain and cosmos. In the human mind, time is measured in the firing of neurons, in the fleeting rhythm of thoughts, in the fragile storage of memory. In the universe, time stretches across billions of years, carving the arcs of galaxies, shaping the slow drift of filaments. One scale seems urgent and fragile, the other eternal and vast. Yet both reveal how structures are born, evolve, and eventually fade. In the brain, neurons are not static. Connections strengthen or weaken depending on experience, shaping who we are from moment to moment. Memories form, shift, and vanish, rewiring the web with each new day. Plasticity, the brain's ability to change, is both its greatest strength and its inevitable vulnerability. The same fluidity that allows growth also allows decay. Synapses fade, networks falter, and the web of thought slowly unwinds with age. Time here is a sculptor and a thief, building identity only to dissolve it. The universe tells a parallel story at a grander pace. Galaxies gather in filaments like droplets clinging to threads, growing brighter as they form stars. Over billions of years, they collide, merge, and transform, reshaping the cosmic web. But the universe, too, is impermanent. Stars burn out, filaments stretch thinner as space expands, and eventually the great web itself may dissolve into darkness. Time is both the architect and the executioner, granting temporary order before entropy reclaims it. The symmetry between the two is haunting. Just as memories flicker and fade within the human brain, galaxies flicker and fade within the cosmic web. Just as synapses shift with every thought, filaments shift as gravity rearranges matter. Both webs are temporary, fragile against the relentless current of time. The brain may last decades, the universe trillions of years, but both are caught in the same current, their beauty defined by their impermanence. And yet, within this impermanence lies wonder. A neuron's brief firing may last only milliseconds, Yet in combination it creates an entire lifetime of awareness. A star may burn for only a few billion years, yet in doing so it creates the elements for planets, for life, for thought itself. Ephemeral sparks, whether in the brain or the cosmos, ripple outward in ways far larger than their duration. Time does not erase meaning. It amplifies it, giving weight to fleeting moments precisely because they cannot last. Here a deeper question emerges. Is impermanence not a flaw, but the essence of existence? If the brain were unchanging, there would be no memory, no growth, no identity. If the cosmos were static, there would be no galaxies, no stars, no life. Time, in this sense, is not the destroyer but the enabler, the very condition that makes structure and awareness possible. The tragedy of transience is also its gift. To reflect on this is to feel a dual emotion, sorrow at the inevitable fading of all things, and awe at the beauty created in the meantime. The neuron and the galaxy, the memory and the star, are luminous not despite their impermanence, but because of it. In their brief existence, they leave traces, connections, elements, echoes, that ripple far beyond their own span. Time may dissolve the web, but it cannot erase the meaning woven within it. To stand in this truth is to realize that we too are part of the same pattern. Our thoughts, fleeting though they are, echo the larger story of galaxies. Our lives, brief though they may be, are verses in the cosmic poem. The filament of neurons and the filament of galaxies are both threads in the same tapestry, written in the language of time itself. If there is one element that deepens the parallel between brain and cosmos, it is the mystery of the unseen. Both networks are shaped not only by what we can observe, but also by invisible forces that guide and sustain them. In the brain, this hidden world exists in the chemical whispers of neurotransmitters, in the faint electromagnetic fields that ripple between neurons, in processes we still cannot fully detect. In the universe, the unseen is even more dramatic. Dark matter, an invisible substance outweighing all visible matter, and dark energy, a force pushing the cosmos apart. In both cases, the unseen is not peripheral, it is central. In the brain, the firing of a neuron is only the visible tip of a deeper process. Without neurotransmitters, the spark cannot leap across the synaptic gap. Without the subtle balance of chemistry, the network collapses. Most of what gives rise to thought happens beyond our conscious awareness, in realms of the mind we can barely measure. The same is true of the cosmos. Galaxies shine brightly, but their glow is only a fraction of the story. Invisible halos of dark matter envelop them, shaping their formation, binding them to filaments. Without this unseen scaffolding, the cosmic web would not exist. The parallel is chilling in its precision. What we see, the bright stars or the conscious thought, is only a surface phenomenon. Beneath, hidden forces do the real work, constructing order from invisibility. Just as neurotransmitters invisibly stitch neurons into meaning, dark matter invisibly stitches galaxies into filaments. Both systems remind us that the most essential truths often hide behind veils. And then there is dark energy, perhaps the greatest enigma of all. A force accelerating the expansion of the universe, it acts like a silent tide, stretching the cosmic web thinner with every passing moment. In the brain, the analog is not yet clear, but perhaps it is the slow erosion of time, the unseen processes that wear down connections, the entropy of thought. If dark matter is the builder, dark energy is the undoer, balancing creation with dissolution. The symmetry holds. Both networks are shaped by what we cannot see, by forces that remain nameless, perhaps unknowable. This hidden scaffolding raises unsettling questions. If most of the brain's workings are unconscious, Are we truly aware of ourselves, or merely of the surface layer of thought? If most of the universe is dark, are we perceiving reality at all, or only its faint visible edge? The parallel forces us to confront the limits of perception. We live inside systems whose foundations we cannot touch, whose rules we cannot fully decipher. Yet within this mystery lies wonder. The fact that unseen forces exist does not diminish beauty, it deepens it. It reminds us that the universe is larger than our understanding, that the mind is richer than our awareness. The unseen does not make existence fragile, it makes it profound. The cosmic web and the neural web are both testimonies to a truth greater than visibility, that the most important structures in life and reality are not the ones we can see, but the ones that invisibly hold everything together. And so, the mirror between neuron and galaxy sharpens. Both are constellations floating on invisible seas. Both are held by forces we cannot fully grasp. Whether it is neurotransmitters or dark matter, subconscious currents or dark energy, the lesson is the same. The unseen is not emptiness. It is foundation. It is the silent architecture of reality. Consciousness has always been the most elusive mystery of the human brain. Billions of neurons, each firing in patterns of electricity and chemistry, somehow give rise to awareness, the feeling of being alive, of experiencing reality from within. How does matter become mind? How does a network of cells generate the sensation of thought, memory, and imagination? This is the great puzzle of neuroscience and philosophy alike, one that mirrors a parallel question in cosmology. Does the universe itself, woven into filaments of galaxies, possess a kind of awareness? The comparison is not idle poetry. When researchers map the large-scale structure of the cosmos and compare it to the neural networks of the brain, the resemblance is uncanny. In both, vast webs of nodes and connections exchange information across immense distances. In the brain, it is electrical impulses leaping across synapses. In the universe, it is gravity and light shaping galaxies into filaments. Both systems are not just static structures. They are dynamic, exchanging energy and information, evolving over time. And this raises a provocative possibility. If the brain gives rise to consciousness through its web, could the cosmic web be the architecture of a larger, universal consciousness? Some philosophers and scientists hint at this idea through the lens of panpsychism, the notion that consciousness is not an emergent property of matter, but a fundamental aspect of reality itself. In this view, awareness exists in degrees, woven into the fabric of everything from atoms to galaxies. The brain is simply a particularly concentrated form, a vessel where consciousness organizes itself into complexity. The universe, on the other hand, may be consciousness diffused across incomprehensible scale, its awareness not like ours, but still present in ways beyond imagination. The emotional weight of this possibility is staggering. To entertain the thought that the cosmos itself might, in some sense, be aware is to dissolve the barrier between self and universe. Our thoughts would no longer be isolated sparks in a small, fragile brain, but resonances of a far greater mind. In this vision, when we look at the stars, we are not just observing them, they are, in some unfathomable way, observing us back. And yet, doubt presses in. Consciousness in the brain is tied to signals, patterns, structures we can measure. The cosmic web, though similar in shape, lacks the clear pathways of information transfer that make awareness possible in neurons. The comparison, critics argue, is metaphor, not reality. The universe may resemble a brain in form, but resemblance does not imply equivalence. To call the cosmos conscious may be to project our own mystery onto the stars, confusing analogy with truth. But even if the universe is not conscious in any literal sense, the parallel retains its power. It forces us to ask, what is consciousness really? Is it confined to the human brain, or is it a principle of complex networks wherever they arise? If neurons give rise to awareness here, could other kinds of structures, whether artificial intelligences, alien civilizations, or cosmic webs, do the same elsewhere? The brain becomes not a singular miracle, but a hint of a wider pattern, a clue that consciousness may not be unique to us. The mystery remains open, suspended between awe and doubt. Perhaps consciousness is a fragile accident of biology, destined to vanish with the last human thought. Or perhaps it is woven into the very structure of reality, destined to outlast us in forms we cannot yet fathom. Either way, the mirror between brain and cosmos compels us to wonder, are we thinking beings inside an unconscious universe, or conscious sparks within a universe that is, in some vast and alien way, awake? Information is the currency of both the mind and the universe. In the human brain, neurons fire not just randomly, but in intricate sequences that encode memories, ideas, and emotions. Every thought you've ever had, every image you've conjured, every word you've spoken has been the result of information moving through a vast network of connections. Without this flow, the brain is silent, empty. And when we look outward to the web of galaxies, we find that the cosmos too is a vast system where information flows, through light, through gravity, through the subtle ripples of space-time itself. Consider light as a messenger. Every star emits photons carrying the story of its birth and its age, its chemical makeup, its distance across the cosmos. When those photons arrive on Earth billions of years later, they paint an image on the retina, which itself translates into neural signals, becoming perception. In this sense, the information of galaxies travels directly into our brains, woven into our very awareness. The cosmic web transmits knowledge across unimaginable gulfs, just as the neural web transmits memory across the synaptic gaps of thought. In physics, some scientists go further, suggesting that the universe itself is fundamentally an information system. Theoretical frameworks such as digital physics or the holographic principle propose that reality, at its most basic level, may not be particles or forces, but bits of information woven together like code. This view resonates deeply with the brain, where consciousness is not a thing but a process, a continuous flow of encoded signals. If the brain is an information processor, and the cosmos is structured as information, then the parallel between neuron and galaxy becomes more than a visual rhyme. It becomes a philosophical bridge. But this raises unsettling questions. If information underlies reality, who or what reads it? In the brain, the reader is us, the conscious awareness that interprets neural signals into meaning. In the cosmos, there seems to be no central observer, no single mind to translate the data. Or is there? Could life itself, scattered across galaxies, be the universe's way of reading its own information, of becoming aware of itself piece by piece? The emotional effect of this possibility is profound. It suggests that consciousness is not a detached accident, but an essential phase of the cosmos, the universe learning its own structure through the beings it creates. Every act of thought, every gaze at the stars, is the universe reflecting upon itself. The brain and the cosmic web are not separate systems, but complementary mirrors, both made of nodes exchanging information, both engaged in the same fundamental act, the circulation of meaning. And yet we are left with the tension between certainty and mystery. The brain's information system can be measured in electrodes and scans. The universe's information system remains largely theoretical, glimpsed only in equations and faint patterns. Between the clarity of neuroscience and the speculation of cosmology lies a gulf of unknowing, a reminder that even as patterns emerge, the truth remains hidden. Still, the symmetry holds us captive. Information flows in synapses, and it flows in starlight. Meaning emerges in thoughts, and meaning emerges in the grand arrangement of galaxies. To live is to be part of both, to carry within the skull a miniature cosmos of signals, while existing within a universe that itself may be a vast, eternal computation. The brain remembers. The universe records. Both are libraries of time, both writing themselves into the fabric of existence. Scale is the dividing line that both separates and unites the brain and the cosmos. At first glance, the comparison seems absurd. The brain is a fragile organ, weighing little more than a kilogram, confined within the bone cage of a human skull. The universe, by contrast, stretches over 90 billion light-years, with filaments of galaxies extending farther than any imagination can grasp. How can something so small mirror something so vast? And yet, when mapped side by side, the architectures echo. Neurons and galaxies trace similar webs, their densities, their connections, their distributions, falling within strikingly comparable ranges. The trick lies not in the raw scale, but in the ratios. Both systems occupy a delicate balance between randomness and order. In the brain, neurons are not evenly distributed. They cluster, they branch, they connect in hubs, leaving gaps of empty space. In the universe, galaxies do the same. They form nodes of clusters connected by filaments, separated by vast voids. The similarity persists even when you strip away the visual metaphor and study the mathematics of their networks. Researchers have found that the distribution of matter in the cosmos and the distribution of connections in the brain share a statistical kinship. Despite the brain's millimeter gaps and the universe's megaparsec voids, the pattern repeats. But scale itself tells a deeper story. The brain's network exists to give rise to thought. The cosmic web's network exists to shape galaxies. One operates on milliseconds, the other on billions of years. Yet both rely on the same principle: complexity arising from simple connections, emergent order from a sea of chaos. Scale then becomes not a barrier, but a mirror. The brain is a cosmos in miniature, and the cosmos is a brain stretched across eternity. The emotional weight of this realization is staggering. To think that inside your head exists a structure that mathematically reflects the entire universe is to feel both humbled and elevated. You are small, impossibly small, compared to the vastness of space. And yet, within you is a model of that vastness, a living echo of its design. In this light, the difference of scale becomes irrelevant. The brain and the cosmos are not rivals but partners, two variations of the same universal song, sung at different pitches. And yet, scale does matter in one crucial way. It reveals perspective. The brain cannot step outside itself to see its total structure without tools. The universe cannot reveal itself in one glance without billions of years of light traveling to reach us. Both systems conceal their wholeness from within, forcing discovery to be piecemeal, fragment by fragment. Scale teaches us humility. It reminds us that even if the patterns repeat, our understanding will always be incomplete, limited by vantage point and time. Still, the symmetry endures, and with it a profound question. Is scale just an illusion? If the same patterns repeat in neurons and galaxies, then perhaps the universe is not about size at all, but about structure. A human brain and the cosmic web may be vastly different in measurement, but identical in principle. The small and the large may be reflections of a deeper law, a hidden order that transcends distance, time, and dimension. Time is the hidden thread binding both the human brain and the cosmic web, yet each experiences it in radically different tempos. In the brain, time is a flicker, electrical signals racing across synapses in thousandths of a second, thoughts arising and vanishing in the span of a heartbeat. The universe, by contrast, moves to a rhythm so slow it almost feels eternal. Galaxies form over hundreds of millions of years, filaments stretch and evolve over billions, and the cosmic web itself shifts on scales longer than the lifetime of stars. And yet, despite this gulf of pace, both brain and cosmos share a striking similarity. They are networks defined by memory, change, and impermanence. In the brain, memory is the architecture of time. Every connection that strengthens, every synapse that weakens, encodes the story of who we are. Neurons that fire together wire together, carving patterns of remembrance. The brain does not merely exist in the present. It is a tapestry of past experiences, constantly reshaped by the passage of seconds and years. Time is written directly into its structure. The cosmic web, too, is a memory, though one written across the fabric of space-time itself. Each filament holds the history of galaxies. Each cluster carries the imprint of collisions and mergers from epochs long before Earth formed. Light traveling through the web is itself a time capsule, arriving at our telescopes after journeys of millions or billions of years. When we gaze at distant galaxies, we are not seeing them as they are now, but as they once were. In this way, the universe too encodes memory. Its time stretched across horizons so vast they dwarf imagination. And just as memory can fade in the brain, so too can the structures of the cosmos. Synaptic pathways weaken with disuse, neural networks erode with age, and in parallel, cosmic filaments may one day thin as dark energy accelerates the expansion of space, pulling galaxies apart. Both systems are impermanent, caught in the dual forces of construction and decay. The brain loses neurons as it ages. The universe loses coherence as it expands. Time, in both cases, is not merely motion forward. It is the sculptor of decline as well as growth. This shared impermanence sharpens the emotional edge of the parallel. To know that your thoughts are temporary, that your very sense of self rests on fragile patterns that can dissolve, is a humbling truth. To know that the universe itself, vast and seemingly eternal, is also drifting toward a thinning web and a cold, quiet horizon, is to feel both awe and dread. Time consumes all networks, whether measured in seconds or in billions of years. And yet there is wonder in this. For in both systems, impermanence is what allows for transformation. The brain forgets so that it can learn anew, pruning old connections to make way for growth. The universe too transforms, birthing new stars, forming new galaxies, reshaping filaments as epochs pass. Time is not only destruction, it is creativity. Without it, there would be no story, no memory, no change, no becoming. In this light, the brain and the cosmos share a deeper truth. They are not static structures, but living histories. Each thought is a moment in the brain's story. Each galaxy is a chapter in the universe's. Time writes itself into neurons and into galaxies alike, and in doing so, binds the human mind to the stars. Energy is the pulse that animates both the human brain and the cosmic web, a current that flows invisibly yet gives rise to everything visible. In the brain, energy surges as electrical impulses, tiny jolts powered by ions crossing membranes, generating the symphony of thought. Each neuron fires with a voltage of mere millivolts, yet in aggregate the brain consumes about 20% of the body's energy despite its small size. That ceaseless expenditure powers every sensation, every dream, every act of imagination. Without that flow, the brain is silent, a structure of cells without spark. In the cosmos, energy takes grander forms. Stars ignite nuclear furnaces, galaxies burn with trillions of suns, and black holes unleash jets of unimaginable power. The cosmic web is not static. It is alive with motion, galaxies pulled along filaments by gravity, radiation coursing through voids, dark energy stretching space itself. Energy is not simply present. It is the very essence of the universe's unfolding, driving the expansion and sculpting the filaments. Just as neurons cannot exist without electrical fire, galaxies cannot exist without the fuel of stellar birth and death, without the cosmic currents that shape their paths. Yet the true parallel emerges in how energy is organized. In the brain, energy is not wasted. It is directed along pathways, flowing in patterns that create meaning. A random scatter of electrical discharges would be noise, not thought. What makes the brain alive is coherence, the alignment of signals that together give rise to memory, language, emotion. Likewise, in the cosmos, energy is not simply scattered into chaos. It condenses into galaxies, flows along filaments, and carves structures that persist for billions of years. Both systems thrive on channels, on the focusing of energy into forms that endure. Emotionally, this realization reshapes how we view ourselves. You are not merely a body with a brain, you are a flame of energy, organized into the architecture of thought. The universe, too, is not a dead expanse of matter. It is a vast circulation of energy, ordered into patterns of beauty. To see the two together is to feel kinship, that the energy that fires in your neurons is of the same origin as the light that blazes in stars. Both are expressions of the same universal law, written at different scales. But here lies a contrast, one that deepens the mystery. The brain's energy is fleeting, sustained only as long as blood flows and oxygen fuels the cells. When that ceases, the energy dissipates and the self vanishes. The universe, however, holds energy that seems eternal, conserved across all transformations, never destroyed but only reshaped. This contrast raises a haunting question. If your thoughts are built from the same energy that fuels the stars, why does one vanish into silence while the other endures across eternity? Perhaps the answer lies in organization. The brain's fragile architecture allows energy to become consciousness, but only temporarily. The cosmic web's architecture is broader, more enduring, but perhaps less delicate, never quite reaching awareness. Or perhaps both are steps on a continuum of energy's self-organization, with consciousness flickering briefly here while the cosmos holds an awareness so vast and slow we cannot recognize it. Either way, the symmetry reminds us of our place. We are energy arranged into thought, existing within a universe that is energy arranged into stars. The pulse in your neurons and the blaze of a galaxy are not opposites, but siblings, born from the same primordial fire of the Big Bang. To feel that connection is to stand in awe. The energy that thinks within you is the universe, for a moment, becoming aware of itself. Consciousness is the great divide between the human brain and the cosmic web, or so it seems. The brain does not merely process signals. It produces awareness, the vivid inner world of thoughts, sensations, and imagination. billions of neurons firing in coordinated patterns give rise to the mysterious phenomenon of subjective experience, the feeling of being you. Yet when we look outward, the cosmic web, vast and intricate, appears silent, mechanical, unaware of itself. It is a network without a mind, a structure without reflection. But is that truly the case? Or are we too narrow in our definition of consciousness to see the possibility that the universe itself might harbor awareness on a scale beyond comprehension? In the brain, consciousness emerges not from individual neurons but from their interconnectedness. A single neuron knows nothing, but billions together create a field of meaning. Could the same principle apply to the cosmos? A single galaxy may be like a lone neuron, blind and mute. But woven into the filaments of the web, could galaxies collectively form a system with emergent properties? A cosmic consciousness stretched across light years? The very thought borders on the mystical, yet it is not entirely without grounding. Complexity science shows us that when enough parts interact, new properties emerge that cannot be predicted from the parts alone. If this is true for neurons, why not for galaxies? Philosophers have long wrestled with this question under the banner of panpsychism, the idea that consciousness is a fundamental feature of reality, present in some form at every scale. In this view, the universe is not dead matter, but matter infused with awareness, from the smallest particle to the largest cluster. The brain then would not create consciousness from nothing, but instead concentrate and channel it, much as a lens focuses light. By contrast, the cosmic web might diffuse consciousness, spreading it thin across billions of galaxies, making it invisible to us, yet present nonetheless. The emotional weight of this possibility is staggering. If the universe itself has consciousness, then our own awareness is not an isolated spark but a local flare of a much greater fire. We would not simply be observers of the cosmos but participants in its living mind. To think, to dream, to wonder at the stars would then be acts of the universe reflecting upon itself. The brain and the cosmic web would not be mirrors of each other by chance, but by design, two manifestations of the same underlying awareness. Yet here, contrast grips us. For all the beauty of the idea, evidence is thin. Neuroscience can measure brain activity, map correlations between patterns of firing and states of mind. But in the cosmic web, we see no such signals, no obvious signs of thought. The silence of space seems to mock the idea of cosmic awareness, reducing it to poetic speculation. Between the measurable mind and the imagined cosmos lies a gulf of doubt. And perhaps that contrast is the point. Consciousness itself is the ultimate mystery, impossible to pin down fully even in the human brain we live inside. If we cannot yet solve the riddle of our own awareness, how could we hope to grasp the awareness of the universe? The mirror between neuron and galaxy is not proof, but invitation, a question posed to our imagination. Is the universe alive in ways we cannot yet detect? To dwell on this question is to stand at the edge of wonder and fear. If the answer is yes, then we are fragments of a mind that spans galaxies. If the answer is no, then consciousness is a fragile accident, blooming briefly in the skulls of beings on one small planet before vanishing into silence. Neither possibility humbles us. Neither possibility binds the fate of the human brain to the cosmic web, forever linked in mystery.